Unit 3, Day 4, reciprocal graphs. We're going to graph secant and cosecant. So to graph the secant cosecant functions, these are the steps that you can follow. We're going to go ahead and wait to talk about those as we are going through the problem. So we're going to graph cosecant cosecant from negative 2 pi to 2 pi. Remember that cosecant is the reciprocal of sine, so 1 over the sine of t. And so it will have vertical asymptotes wherever, of course, the sine of t is equal to 0. Because our graph is undefined at these places. And remember, we've been talking about irrational functions, and anywhere you have a 0 in the denominator, it either is a whole or vertical asymptote. In this case, if it's left in the denominator, it's a vertical asymptote. So when we're graphing these, the easiest way to graph would be to graph your reciprocal function. So right now we're going to be graphing y equals CSC, so cosecant of t. So to help us graph this, we're going to graph the reciprocal, y equals the sine of t. So for this, we know that for the sine of t, the period is 2 pi. And so we know that then that means the key points, we take our period and divide it into 4 equal parts. So 2 pi divided by 4 gives us pi over 2, which we learned before. So my key points for cosecant and sine are going by pi over 2. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, and then 4 pi over 2 is just 2 pi. And of course, we want to go to the negative direction as well. And for this, if I'm graphing the sine graph, remember sine of 0 starts at 0 and then moves up to 1 and then moves down to 0, negative 1, 0. So this is the first wavelength of our graph, and of course we can go backwards, and so we've already talked about graphing our sine and cosine functions, so hopefully you know how to do this by now. So now that we have graphed our sine functions, that was the first part. So we graph the sine or cosine, make the transformations, then you're going to graph the vertical asymptotes. So everywhere where sine is equal to 0, that is a vertical asymptote on your graph because, again, we can't divide by 0. So we're going to go ahead and put that on our graph. So here is the first place where our sine graph hits 0. So that's our first asymptote. The next place it hits is at pi, and then 2 pi, and negative pi, and negative 2 pi. So that's where our asymptotes are, our graph are. And so then the next step, it says, is change all the maximum points to minimum points and all the minimum points to maximum points. So if you think about this problem here, notice that on our sine graph, right around this area, we're very, very close to 0. So we're doing cosecant, which is a reciprocal of sine, so 1 over sine. So if I have 1 over a very small number, remember it becomes a very large number. So right here at this point, we have pi over 2, 1. So if I think about doing 1 over 1, because that's for the cosecant, 1 over 1 is just 1, so that point is why that stays there. Same thing if I did 1 over negative 1, so that's why all your maximums and your minimums are going to stay. They're just going to become the opposite. So if this point at pi over 2 is a maximum, it's going to become my minimum. So as I get closer and closer here to 0, I know that 1 over a very small number is a very large number, so your graph just goes up and follows your asymptote. Same thing here. It's instead of going to go up, because we're in the negative side of the graph, we know that 1 over a very small negative number is a very large negative number. So that right there in the blue with the asymptotes is the first cycle for the cosecant of t. So if we want to graph another cycle, same thing here. So I can go down, and then this one would go up. So that would be 2 cycles of my cosecant t. So the domain, you'll notice, is no longer all real numbers because we have these asymptotes. So how do you find the asymptotes? You look at the first place where you have a vertical asymptote. So the first place I start is at x equals 0. So that means my domain is going to be all real numbers not equal to the first place where your asymptote is 0. And notice the next place is at pi, and every single pi is where we have our asymptotes at. So basically, whatever the period is, if you divide that in half, that's going to give you what you're adding for your asymptotes. So 0 plus pi n. So again, that's just half the period. And so that would be the range, because we could write each interval out if we wanted to, but that would be a lot to do because it goes on forever. So that's why we're going to just write our domain as I wrote it here. Of course, that's the same thing as saying all real numbers not equal to pi n. So our range now, you'll notice that we have negative infinity to -1, and we're including -1, and then we're going from 1 to infinity. The period is still, to make one complete cycle, we have this upper region part and this lower region part. So a parabola that goes up and down, so that means it's still 2 pi. And our key points are still going to be pi over 2, because again, it's the period divided into 4 equal parts. So 2 pi divided by 4 is pi over 2. So it's the same as our reciprocal graph sine of t. So now keep in mind that this graph right here, the sine, is not actually part of the graph. So really, I would actually erase this graph. So erase the sine graph when you're done, because it's not really a part of the function. We know that because our sine graph is odd, that means that our cosecant graph is odd. So it's an odd function, which means that the cosecant of -t is equal to the cosecant of t. And remember, odd functions have origin symmetry. And that would do it for our cosecant graph. And so let's go ahead and look at the next one. So the next one we're going to take a look at is the secant. So we know that the secant of t, the reciprocal, is the cosine. So secant t equals 1 over the cosine. So that means everywhere we have cosine of t is equal to 0, we have asymptotes, because we know that the graph is undefined where the cosine would be 0, because you can't do 1 divided by 0. So in order to graph y equals the secant of t, we want to use our reciprocal function, which we know is cosine. So we're going to graph y equals the cosine of t. So we know that the period of this graph is equal to 2 pi, and we know that the key points are pi over 2, just like sine. So on our graph, we have pi over 2. Then we have pi, 3 pi over 2, and 2 pi. And then, of course, we want to graph from -2 pi to 2 pi, so we're going to go in the negative direction as well. Okay, so for this, we're going to go ahead and graph our cosine graph. And so we know the cosine graph at cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. 3 pi over 2, the cosine is 0 and 1. So this is our first wavelength. And of course, we can go backwards. And now I have my second wavelength. So then next thing I want to do is everywhere my cosine is equal to 0, that means we are going to have an asymptote on our graph. So again, that's going to hit here and here, and also here and here. So for this, just like our cosecant graph, everywhere we have a maximum then becomes a minimum. So right here at 0, 1. If I were to do this, since we're doing the secant, it's 1 over cosine. So 1 over 1 is equal to 1. And as you get closer and closer to your x-axis, you're going to have 1 over a very small number, which means you have a very large number. So this right here would be my first part of my first graph. And then everywhere I have a minimum, I know that becomes a maximum. And again, that would be the next part of my graph. And we're just going from -2 pi to 2 pi, so I'm not going to draw the other side of this parabola here. And this one would go down and up. So that's graphing from -2 pi to 2 pi. If you look, the actual first cycle starts from here to here, so it's part of the parabola. So it starts from 0 to 2 pi, and you can see that's what's repeating. Notice that my first asymptote is at x equals now pi over 2, not 0. So the domain would be all real numbers not equal to pi over 2 plus, and then half the period. So the period's 2 pi, half of that is pi, so we're adding pi times n, where n is an integer, to get all the places where we have our vertical asymptotes. So your range is still the same. It's going to be negative infinity to -1 bracket and 1 to infinity, periods to 2 pi, and the key points we are still using pi over 2. And of course, remember that if this is our secant graph, we would want to erase our sine graph. So erase sine, not sine, sorry, cosine, because we're doing secant cosine graph, because it's not really part of our graph. So another thing we want to talk about is the fact that our cosine function is even, which means that secant is even. And so that means that the secant of negative t is equal to the secant of t because it's an even function. And we know that even functions have y-axis symmetry. And that's it for our secant graph. So let's go ahead and do some practice of some transformations now. So for the next problem, we're going to graph 2 times the secant of t minus 3. So of course we always want to write down our each of our values that we have. So the secant actually doesn't have an amplitude, neither does the cosecant. So let's go back to these graphs real quick. Then an amplitude is the distance that you're oscillating back and forth between. And because this graph is just going up and down, we don't really say that it's an amplitude, so we're just going to call it our A value. So in this case, our A value is equal to 2. My B value, remember, is what is attached to the x, so there's nothing there, so we have a B value of 1. And we have this is our D value. So our D value means our midline's at -3. So if our B value is 1, remember we use the period. So B times the period is equal to 2 pi. So if I'm solving for the period, it's 2 pi divided by our B value. So in this case, that means the period is equal to 2 pi. We haven't changed it, which means my key points are still going by pi over 2. And the next thing that we want to do is go ahead and start to graph this, starting with our key points. So with our key points, we know that we're counting by pi over 2. So 1 pi over 2, 2 pi over 2 is just pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2, 6 pi over 2 is 3 pi, 7 pi over 2, 8 pi over 2 is 4 pi, and then 9 pi over 2. So that would give me my key points on my graph. Of course, don't forget to label your y-axis as well. So 2, 4, 6, and -2, -4, and -6. So when I'm graphing this, because we're working with secant, I know the reciprocal of secant is the cosine. So we're actually going to think about y is equal to 2 times the cosine of t minus 3. So if I were to graph this, I would, of course, put my midline on my graph because that helps me see what I'm oscillating back and forth between. So my midline is right here at -3. And then we know the cosine t, what's happened to our graph. We had a vertical stretch by 2, and we also moved our graph down 3. So the midline takes care of the down 3. And cosine normally starts at 1. However, we have an amplitude of 2, so now our cosine graph is going to start here. And then we would go to our midline, and then again, our amplitude's 2. So if I count 2 down from the midline, back to the midline, and now I'm here. So this would be the transformations made to that cosine graph. So that's the first wave. And then of course we can graph the second wave. So there's 2 cycles. So now we want to go back because we're really graphing the secant graph. So everywhere my cosine graph is 0, that is going to give me an asymptote. Well, now we've moved our midline down, so that means that wherever our cosine graph, um, or if we're working with sine, wherever they cross the midline, that's where your new asymptotes are. So we have an asymptote here, which is still at pi over 2 because we didn't change our period of our function. And here, and the next one would be here, and then right here at 7 pi over 2. Whoops, that line's a little crooked. And so now I'm going to go ahead and actually graph my secant graph. So everywhere I have a maximum, that becomes a minimum. Remember, your graph just follows your asymptotes, so that would go this way. Here's where we'd start for the next one and going down following our asymptotes. And this part goes up and down. And this would be 2 cycles of my graph. So again, that graph in red is not there, so then I would go ahead and actually erase that graph because it's not really part of your graph. It would just be the asymptotes and, of course, the graph that's in green. So let's go ahead and look at the domain and the range of this. So your domain, again, is the first place where you have an asymptote, which is x equals pi over 2. So the domain is going to be all real numbers, not equal to my first asymptote, which is pi over 2, plus half the period. So the period's 2 pi, half of that would be pi over, half of pi, 2 pi was pi, excuse me, so plus pi n. And the range has changed now, so now we're going from negative infinity to negative 5, and then from looks like negative 1 to infinity. And that would be my graph for my 2 secant t minus 3. So let's go ahead and look at the next graph. So for the next graph, we have the cosecant of t. Cosecant, the reciprocal we know is the sine. So I'm going to go ahead and write that down first. So y is equal to negative 2 times the sine of t plus 1. So I'm going to graph this graph first, and then I'm going to change it into cosecant. So for this graph, our a value is equal to negative 2, and our b value is equal to 1, which means my period is still 2 pi, which means my key points are still pi over 2. And my d value is equal to 1. So if we were actually talking about the amplitude, though, remember the amplitude is the absolute value of that a value. So the absolute value of a means it has an amplitude of 2. I'm going to use the negative, though, for right now so that we know that's just the a value that we're talking about, which is a reflection across our x-axis or midline. So when I'm graphing this out, we know that, again, I start with my key points on my graph. So this is pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and 4 pi, and 7 pi over 2, and 5 pi. And so then, of course, oops, I missed the 3 pi. That's not my fault. 3 pi, and this would be 4 pi. All right, so for this, we know that our midline for this graph is at 1. So I'm going to put, oops, 2, 4. So our midline is at 1 because of that plus 1. And we're now graphing our graph with the sine. And of course, because of that negative, we know that is a vertical stretch by 2 and a reflection across the x-axis. So instead of going up from the midline, we're going to go down. So we're going to start at the midline, and the amplitude is 2, so we're going to go down 2, back to the midline, up 2, and back to the midline. So this would be my sine graph with a vertical stretch of 2, but reflected across the x-axis and moved up 1. So that's the first cycle, and then of course we're just going to repeat that to get the next one. And this is why we spent so much time graphing these functions before. So then the next step, of course, is that we want to graph our cosecant graph, which means everywhere our sine graph hits the midline, that's where our asymptotes are going to be. So there's one that starts at 0, and then there's one here at pi, and 2 pi, and 3 pi, oops, and 4 pi. And now I'm going to actually graph my cosecant graph. So this right here becomes a maximum, and my graph goes and follows my asymptotes. Same thing over here. And down here. And up here. And of course, then I would erase that graph in red because it's not part of my actual graph. So now the domain, again, is the first place where we get an asymptote, which is starting at 0. So our domain is going to be all real numbers, not equal to 0 plus half the period. So the period's 2 pi, half that's pi, so plus pi n, which you can also write as not equal to pi n. It's the same thing. And then your range is now from negative infinity to negative 1, and from, let's like 3 to infinity. And that would be it. So let's go ahead and do one more graph. This time we're going to actually introduce a period change. So for this next graph, we have cosecant, which again is reciprocal for sine. So y equals 3 times the sine of 1/3 t. Now I have an a value of 3, but my b value's changed to 1/3. So remember that b value changes the period or wavelength of your graph. And we're going to use this equation to help us. So that means that the period is equal to 2 pi divided by our b value. So 2 pi divided by 1/3 is equal to 2 pi times 3 over 1, which is 6 pi. So now that I have 6 pi, we can find our key points. So your key points, of course, go by taking your period and dividing it into 4 equal parts. So in this case, 6 pi divided by 4 would be equal to 3 pi over 2. So we're going to use that on my graph. So I'm going to go ahead and start counting those out. So we have 3 pi over 2. I'm going to write it down here. So that's going to go up here. And we're going to add another 3 pi over 2. So 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. But that, of course, reduces into 3 pi. And then 9 pi over 2. And then 12 pi over 2, which gives us our 6 pi. 15 pi over 2. And then 18 pi over 2, which would be 9 pi. So 21 pi over 2. And then the next one would be 12 pi. Oops. 4. All right, so for this graph, our midline is just our d value, which hasn't changed. It's at 0. So I'm going to go ahead and graph that first because I know my graph. That helps me figure out where my asymptotes are. My graph has to go back and forth between that. So again, we're just graphing the sine graph first. So sine graph starts on the midline on the y-axis, and it's an amplitude of 3, and it's positive. So we're going up 3 from the midline, back to the midline, down 3, and back to the midline. So that right there would be the first wave, and then I could graph another one just by repeating those values. So that would be my second wave. So now that I have that, I want to put the asymptotes on my graph. So everywhere my graph hits my midline, those were my asymptotes, which starts here at 0. Next one's at 3 pi. And the next one's at 6 pi. And then 9 pi. And then 12 pi. And then we need to go ahead and graph the actual cosecant graph. So everywhere we have maximum becomes minimum. So that would be here, and then a graph follows our asymptotes. And then here, and here, and down here. So that would be 2 cycles shown. So then, of course, I would erase my graph that's in green. And so now I have my 3 cosecant 1/3 t graph. So I erased that this time so you can see what it looks like. So my domain, in this case, the first place where I hit is at x equals 0. So all real numbers not equal to 0 plus, but now notice that the distance to the next one has changed. So remember we said it's always 1/2 your period. So notice my period is 6 pi. So half of that, so divide that by 2, and I get 3 pi, which makes sense because you can see that the next key point is here at 3 pi. So 0 plus 3 pi n, or you could just say not equal to 3 pi n, because we don't really need that 0 there. And my range is going from -infinity to -3, and then it looks like 3 to infinity. And that'll be it. So just have to remember you're graphing whatever the reciprocal function is. And then, of course, once you graph those reciprocal functions, wherever your graph for sine or cosine crosses your midline, that's where your asymptotes are going to be. And then from there, you can graph your actual secant or cosecant, and then remember to erase your reciprocal graphs because we only use them to help us graph. And that's it for our secant and cosecant graphs.